Hello and welcome. This is the second video that I'm doing on regression modeling. In the first video on regression modeling, I explained at a very high level what regression modeling is and the different types of techniques that can be used in regression modeling. In this video and the next video, I will be solely focused on linear regression. In this video, I'm going to run you through a couple of equations on how to solve it yourself. And actually with linear regression, this is something that can be solved by hand. So what I'm going to do is I'm going to actually go through an example with some test data, and we're going to solve it by ourselves, by hand, without using any Python code. But in the next video, we're going to go into my Python shell, and I'm going to show you how you can use linear regression in Python with a really great module called sklearn. So let's get started. Remember, in the last video on regression modeling, I showed you this slide where linear regression assumes that there is a straight line of best fit with the data, and it can be calculated by using the equation y equals a plus bx, where a is the y-intercept, which is the y value when x is 0, and b is the slope or gradient of the line. In the last slide, I said we'll go into this in more detail at a later date. Well, this later date is here and now. So let's go into more detail about linear regression. Okay, so in the previous slide, I mentioned the equation y equals a plus bx. But some people also use y equals mx plus c. But we will refer to our previous one where we had b as the slope and a as the y-intercept. To be honest, it doesn't matter what you call it. It is something x plus something. Y equals something x plus something. So the first thing we need to do is we need to get our equations together and have everything in one place so we know what formula to use and how to solve it. So the first thing is, the first formula, the one you see on the left, b equals, and this is how you can get the slope. So b equals, and then you see that lovely little equation there on the left. Don't worry, we'll go through it step by step. And in this case, n is the number of values in the dataset. But don't worry, we'll go over this in literally step-by-step detail. And a on the right, that is the formula for calculating the y-intercept. So b on the left is how you get the slope, and a on the right is how you get the y-intercept. Notice that the function for a has b in it, so the first thing you need to do is you need to calculate the slope before you can calculate the y-intercept, which sort of makes sense in your head when you think about it. Remember, n is the number of values in the dataset that you have, but let's go through this now and solve these formula step by step. Okay, so let's go through an example. So I've got a table here, and let's say you start with x and y. You start with just x and y here. So these are your values for x, 1, 2, 3, 4. And your values of y is 10, 15, 20, 25. So that is your data sheet. Just these first two columns here in this top table. What you then need to do is you need to add on these three columns on the right, labeled xy, which is x times y, literally in this case 1 times 10. And you have to also have x squared and y squared as the extra columns. Forget the table below for the time being. And so what you can then do is to get xy, you multiply x, the first row of x, by the first row of y, and you get xy, which is 10. 1 times 10 is 10. And then x squared is the next one, which is literally squaring x value. So 1 squared is 1. And then same for y squared. 10 squared is 100. And then do the same for 2. 2 times 15 is 30. 2 squared is 4, 15 squared is 225. Then you do the same for 3, and then you do the same for 4. So in this example of the data set here, in this data set example, we've got 4 values in the data set, because you've got 4 rows. In this case, a value is an x and y combination. So we've got 4 sets of x and y. Cool. So after you've added our x, y, x squared and y squared columns, we can now go to the bottom of our data set and we can add in this sigma function. This sigma means sum. So we have the sum of x, the sum of y, the sum of xy, the sum of x squared, the sum of y squared. Simply meaning the sum of this column here in the data set, the column sum of this, sum of x squared, and the sum of y squared. That's all we're doing. We're adding these data sets right off. So the sum of x is literally 4 and 3 and 2 and 1, which is 10. The sum of y is 25 and 20 and 15 and 10, which is 70. So sigma y is literally the sum of y, but in a really fancy way. Well, Greek way, shall we say. Do the same for xy, and get the sum of it. Sum of x squared, sum of y squared. Cool. So after you've added these 3 columns and created the table below, we've now got everything we need to then plonk these values into this formula above, and we can get our slope and y-intercept. So let's do that. Let's take our b formula and get the slope. So b equals n. Remember, n is the number of sets of values that we had, which is 4. So we have n is 4. Sum of xy here, go back here. Sum of xy here, we had x times y. We've got the sum of it, it's 200. So you plonk 200 in there as well. Minus the sum of x times by the sum of y. Sum of x, remember, is 10. Sum of y is 70. So you plonk that in there here as well. And then we do the same for the one below. We simply refer to our table that we created in the previous slide here. And then we just plonk these numbers in. And the sum of x squared is, sum of x is 10. And the squared here, well, I've done it to the power of 2, which is the same as squared. And then, so what we can do now is we just sort of, 4 times by 200 is 800. 70 times by 10 is 700. You get 800 minus 700. 4 times 30 is 120. Minus 100 is 20. 100 over 20 is 5. So the slope is 5. And you can sort of figure that out because it's such an easy example to work with. So if you start at the 4, 25, you go down 1 to 3, it's 20. So you've gone along 1. So you've gone along x1 and you've gone, the y value has gone down by 5. So each step goes down by 5. So 1 and 5, the gradient is sort of 5. So that sort of makes sense in my head, my mind. So 5 does seem right. So now we've got the slope. We can now use the slope to calculate our y-intercept. And we just do exactly the same thing as we did above. We do the sum of y, which is 70. Go back up, sum of y is 70. 70 minus 5 times by 10. 5 is our value for b here. Plonk that in. 5 times by 10, sum of x, over n is 20 over 4, which is 5. And again, we can sort of try and figure that out. Just have like a ballpark figure in your head. So 4 is 25, 3 is 20, 2 is 15, 1 is 10, and sort of 0 is 5. So yeah, that sort of makes sense. And so now, remember that regression is all about predicting future values using the current or existing data that we have. And so we can now plonk that back into our equation y equals a plus vx to get any y value that we want based upon what the x value is. So we've got, x is 1, x is 2, x is 3, x is 4, and that's the existing data that we have. But we can now use regression modeling to say, what if x is like 1,000? And we can plonk our x as 1,000 in here by using our A value of 5 and our B value of 5, and we can get an estimate of what we predict Y would be if X is 1,000, which is 5,005. So prediction here is that when X is 1,000, Y will be 5,005. And that is what regression modeling is. It's using our current existing data that we have to predict the future values. So I really hope you've enjoyed that tutorial. In the next part, we're going to put this into our Python shell and it will be a great introduction to the sklearn module. After that, we're going to go over polynomial regression. That is much harder to do by hand. In fact, it is so much easier to do in Python and using code. So yeah, it's pretty much right. Doing that by hand is almost I wouldn't do it. And then after that, we're going to go over logistic regression. Exactly the same, part 1 and part 2 every time. So I hope you've enjoyed that tutorial. Please do subscribe to my channel, and I hope to see you in the next video. Thank you very much for watching.